Hello, good day my dear students. Welcome back to this YouTube channel, Mathematics and Me. So for today's video, you will learn the power theorems on circle. We have three power theorems. First, we have the chord power theorem. Second, we have the secant power theorem. And third, we have the secant tangent power theorem. Let's discuss first the chord power theorem. Based from this theorem, it states that if two chords intersect in a circle or inside the circle, then the products of the lengths of the chord segments are equal. So as you can see in this figure, we have two chords. We have chord HJ and chord IK. And these two chords intersect at point A. And also, this point of intersection divides the length of the chord into two unequal chord segments. So the chord segments now are HA and then AJ. That is for chord HJ. And for chord IK, we have chord segments IA and then AK. So to understand this theorem, let's consider this figure with measures. HK is 7, AJ is 12, IA is 8, while AK is unknown. So it is denoted by letter X or a variable X. So to solve for X or to find the value of this chord segment AK, we need to substitute all the values in this theorem or in this equation. So we have HK is 7 times AJ is 12 equals IA is 8 and AK is unknown, so it is X. 7 times 12 is 84 and 8 times X is 8X. To find the value of X, we need to divide both sides by 8. So 8X divided by 8, we have X. And then 84 divided by 8, we have 10.5. So the value of X now is 10.5. It means that AK or chord segment AK is equal to 10.5. Next theorem, we have the secant power theorem. So obviously, there are two secants. These secants are secant PM and secant PO. So based from this theorem, if two secants intersect in the exterior of a circle or outside the circle, then the product of the measures of one secant segment and its external segment is equal to the product of the measures of the other secant and its external secant segment. So this is denoted by this equation. So this is the secant and it is the secant segment. Another secant and its secant segment or external secant segment. So let's consider now this example. Again, to find the value of the unknown variable, you need to get the product of the whole secant segment, let's say secant PM, and the secant segment or the external secant segment PL. So PM times PL. PM is the sum of the lengths of PL and then LM. So the measure of PM is 3 plus 7 or 10. Times PL is 3 equals PO is also the sum of the measure or the length of PN and NO. So PO is equal to 2 plus X. times Pn is 2. So this time, let's multiply 10 and 3. We have 30 equals. So in this part, you need to apply the distributive property. 2 times 2 is 4. And x times 2 is positive 2x. So plus 2x. So this time, it is now a linear equation in one variable. So to solve for x, you need to transpose this positive 4 to the left side of the equation. So it will become 30 minus 4 equals 2x. Next is simplify 30 minus 4, it is 26 equals 2x. So by dividing both sides by 2, you can get the value of x. 2x divided by 2, we have x. And then 26 divided by 2, we have 13. Therefore, the value of x here is 13. Next, another example. So this is again secant power theorem. To write the equation, you need to get the product of the whole secant JA and multiply it to the external secant segment EA. So let's put JA times EA equal to the whole secant SA times NA. So SA times NA. And then substitute the given. JA is equal to 11 plus 4. So 11 plus 4 is 15. So we will put here 15 times EA is equal to 4 equals SA, based from the figure, it is equal to 12. So we put here 12 times NA is x. So let's simplify. 15 times 4, we have 60 equals 12 times x is 12x. So to find the value of x, need to divide both sides by 12. So 12x divided by 12 is x. And then 60 divided by 12 is 5. Therefore, the value of x here is equal to 5. So if the value of x is 5, NA or this external segment is also equal to 5. And if SA is equal to 12, therefore SN is equal to 12 minus 5, we have 7. Next theorem is secant tangent power theorem. So based from this secant tangent power theorem, if a tangent and a secant intersect in the exterior of a circle or outside the circle, then the square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment. So this is the equation of the secant tangent power theorem. The tangent segment here is PM, so you get the square of it. So we have PM squared, and it is equal to the product of the secant segment PO and the external secant segment PN. So for example, the tangent here is PM and it is equal to 10. So let's substitute PM by 10 and get the square of it. And PO, it is the sum of 5 and 3x. So PO, it will be 5 plus 3x times the measure of the external secant segment, which is 5. So 10 squared, we have 100 equals, let's distribute 5 times 5, 25, plus 3x times 5, we have 15x. So we have now another linear equation in one variable. So let's solve for x. Transpose this 25 going to the left, so it will become negative 25. So we have 100 minus 25 equals 15x. Then simplify 100 minus 25, we have 75 equals 15x. And then divide both sides by 15. So 15x divided by 15, you have x. And then 75 divided by 15, you have 5. So the value of x here is 5. However, we are looking for the measure of chord segment NO. So this 3x. So to get the length of this NO, you need to substitute the value of x, which is 5, to 3x. So NO will become 3 times 5, which is equal to 15. So therefore, NO will be equal to 3 times 5, or 15. So this is now the measure of NO. Next example. So the same. The tangent chord here is EV. So we put EV squared equals, the secant segment is LV. So we put here LV times OV. So EV is again 10. So we have 10 squared equals LV is 25 times OV is X. So 25 times X. 10 squared is 100 equals 25 times X. We have 25X. Now divide both sides by 25. So cancel out, you have X equals 100 divided by 25 is 4. So the value of X here is equal to 4. Thank you so much for watching. I hope you learned from this lesson.